Hey, howdy, hey, friends and neighbors. I've got an experiment I've been wanting to try. Let's not put that in your mouth. And I have my lab assistant who's going to help me out here. We're going to test the acidity or alkalinity of some different substances. Now, you may have heard about the importance of eating an alkalizing diet, and one of the foods that you hear talked about are lemons. Lemons are acidic, but supposedly they have an alkalizing effect in your body because of metabolic processes. We're not going to get into that right now. We are going to test an interesting claim that I've heard. I've heard that if you slice up a lemon and put it in water, it can alkalize the water. And I've heard a few different versions of this. The one that sounds the most plausible, because lemons are acidic, the one that sounds the most plausible is that you slice it up and leave it in the water for 12 hours. And then that changes gradually and it alkalizes the water. It might be possible because it might be reacting with the air. There might be something happening between the peel and the lemon. I don't know. There are things that could happen. So let's find out. Oh, I've also heard that it doesn't work with lemon juice, but that it does work with lemon slices. I also bought a lime to try that out, and I bought a grapefruit, but I decided to eat that because I like grapefruit. And we're going to have as our control just regular tap water, and I've already pH tested the tap water. It's pretty neutral. It's maybe very slightly alkaline. Yeah. Looks like about 7.2. Honey. Thank you. So I have 1 cup of tap water in each of these, and I think let's try a tablespoon of juice. Maybe we should try a little less. What if we try 1/2 tablespoon of juice for the juices that we use?
Ooh, hey Daddy, I'll hold it for you.
You want to help me pour it in? Or help me dip it in? Okay, here, hold the spoon over here. We'll test it now, and then we'll test it in 12 hours when the effect supposedly should take place. Okay, pour it in. Good, thank you. Okay, lemon juice. Let's do the same with the, I need to borrow it. Rinse that out in some water.
No, where did you hold it?
Okay, here, you hold it for me to fill it up, and then I'll have to reach over and put it in. Okay, thank you for helping. There's our lime juice. And let's slice up our lemon. This is an awful lot of lemon for just 1 cup of water, so what if we use about 1/4 of the lemon? And they said not to squeeze the lemon, which kind of makes me curious. Why don't you squeeze the lemon? Is it because it has something to do with the pith more than the juices? I don't know. Anyway, I'll slice it into, well, I guess this would be 2/8 of the lemon slices. That's pretty comparable to what you would slice up for a drink. And then the lime, we'll do the same thing there.
Ooh, yummy. Daddy, do you like you making bags?
Oh, good. I like to make things with you.
Yeah, I do want to drink some though too, Daddy.
Okay, lime slices. So, and I'm going to rinse in between every one. Stir this up a little. Got some clean water back there. Lime juice and lime slices. Okay, like I said, I've already checked the water's pH. It's important to know that, to know how much it's affecting things. My prediction right now is that the lemon juice and the lime juice are going to start out being pretty acidic, and that the lemon and lime slices will be slightly more acidic because they haven't had a lot of time for the juices to seep out into the water. So let's check now. Oh, look at that, perfect. Okay. Well, this looks pretty acidic to me. Here we go. I think it goes down below what this scale will show. So far, that's our prediction. Let's pour that in here, and let's rinse it out. Now, we'll get the lemon slice water, which again, I'm not expecting to be very different yet. Probably a little more acidic. And yeah. Well, it turned pretty acidic too, actually. Here we go.
Hey, what do you see?
Okay. Turn yellow.
Daddy, but why are there nothing in that side?
That's if we want to test chlorine and bromine, because this is really a pool test kit. But since this water really shouldn't have chlorine and bromine in it, I guess tap water does have a little chlorine.
Could you hold this for you?
Well, Daddy's gonna. Can I have it? Because Daddy needs it for the lime juice test.
Okay.
Okay. And I will take a screen capture of each of these and put them next to each other, so that's so you can see them compare for acidity 2, 3, 4, 5, and the before and after. Yeah, that's that's acidic.
What do you see? What do you see?
Okay. Very yellow.
Oh, very yellow.
Very yellow.
Yellow. Oh, Daddy, pretty doing. I did it all.
Okay. Thank you, my girl.
Daddy, what is it by you?
And acidic again. I'll have to see them side by side, but I think that the juice is more acidic than just the slices.
What do you see? Oh.
Oh. Now we wait. We're supposed to cover these up. And then we'll come back and try it again in 12 hours and see if anything happened. Okay, we're back. It's 12 hours later. I had to move everything up here because it's too dark in there. So it really should be all under the same lighting, but it's not going to be no matter what. So let's come in here to the better lighting. And I'm really excited to see what, if anything, has happened here. And while I was waiting, I ran some really interesting experiments, but we can talk about those in a bit. I've got all my materials. Let's first check our control, the water. And this, I expect, to have the same pH, which was around 7.2. Okay. It looks to me, if I get it under the light, looks to be about the same to me. How do I? Here. This is awkward. Here we go, white background without the shadow. There we go. Now, the lemon juice. This one, according to the website that I looked at, this one should not have changed. It should still be acidic. Oh, it's looking pretty acidic. Which is what we had expected. What everyone had predicted. And there we go. Let's go ahead and test the lime juice too, since we didn't expect that to change either. And this is looking acidic. Yes, it is. I'm trying to get this where it's, there we go, under the light. I'm trying to line them up in the camera. Next, let's try the lime slices. Or the water sliced lime yet. Now, even if this doesn't work, I had some more thoughts, and we're going to get into that. Some more experiments to try out. That, my friends, is acidic. All right, fair enough. Now, limes and lemons are closely related, being citrus fruit, but hey, you know what? The website never said that limes would do it. It said lemons would do it. Here it is, moment of truth. You know what? Let me make sure that I rinse this out really good. This is the one. This is the test right here. Does lemon water become alkaline after you set it out for 12 hours? Didn't get enough of it. Here we go. I've kind of got my suspicions, but let's see. Ooh, it's not looking good. Let me take a look at it first. I'll have to look back at the video file to compare it, but there we go. That is acidic. Yeah. Now, I added a little bit to this experiment. I have two other versions of this. One where I'm just using the rinds of the lemon. I thought since it said not to squeeze them, maybe something is happening with the rinds. So I have one of those sitting out, but I didn't start it in time to check it now. I just thought of it in the middle of the day. So I'll come back in the morning and check that. And I have one where I've boiled the water first because I did an experiment with, I did some boiling water pH experiments. And let's talk about those now. And so while the lemon water was sitting out to do its thing, I decided to go and do some more tests to see if we could find other ways to make alkaline water. My first idea was, what if we use lemon essential oil? Maybe it's alkaline because essential oil is a very specific part of the lemon and not the entire lemon. And I used some Young Living essential oils and I plunked it in here and it's not as acid as a lemon, but it's certainly not alkaline. So you could use lemon oil to make a less acidic water, but it's not going to make an alkaline water. And then I know that baking soda is alkaline, and I had read online that you can add baking soda to water to alkalize your water. That sounds legit. I put 1/2 teaspoon of baking soda into 1 cup of water, and yep, alkaline water. But it tastes disgusting. I'm sorry, it does. At least I don't like the taste. I had also read online that all herbal teas are alkaline. And that seemed kind of all-encompassing because when you say all herbal teas, that's a lot. So I decided to make several herbal teas and test them out. One problem that I ran into right off the bat is that most of my herbal teas had kind of a yellowish tint to them, the color I mean. So if I had just squirted the tea in and not even added any drops, according to the scale, it would have been acidic. And I'm not sure if the drops were able to get past that sort of prejudice towards acidity that the coloring of the tea naturally had. So you may want to take these results with a grain of salt. I ended up ordering a digital pH scale that it has a little electrode you can stick in the water, and it tells you the exact pH to, I think, to like a 100th of a point. But it's not in yet. When it does come in, I will go back and then I will recheck these for the exact numbers. But let's go with what we have and get sort of a preliminary idea on these teas, knowing that they might be skewed more towards the acid side. Starting off, chamomile tea, which is one of the ones that's supposed to be alkaline, according to wise voices on the internet. And according to the scale, it is slightly acidic. Not really bad, but yeah, on the acid side. Then I tried 3 different strategies on peppermint tea. One was just to use a store brand, a Celestial seasoning tea, and it was a little bit on the old side, so I also pulled out some of my really fresh peppermint tea from Rose Mountain Herb. And then I thought, you know what, I am only preparing these with really hot water. I'm pouring boiling water over them. What if I cold brewed a tea? Would that make any difference?
And no, on none of those. None of them really made much of a difference at all. They all scored as slightly acidic, pretty close to neutral, but slightly acidic. So I'm hoping that that coloration they started with is what's skewing it down, and that when I get the digital scale, I'll actually find out they're alkaline. That's the hope. But so far, I'm going to consider them slightly acidic. I tried another celestial seasoning tea, some of our favorite over here, Sleepy Time Vanilla, and it actually scored fairly acidic on this. Maybe not as bad as a lemon, but still pretty much on the acid side. Ginger tea is one of the ones that is supposed to be really alkalizing, or really alkaline to start with. There's a difference in alkalizing and alkaline, but we can talk about that later. And according to the pH test, it's just a little acidic. Not too bad, like a lot of the herbal teas, but this is another one that was really deeply colored to start with. Then I tried some oat straw, because I had a theory that maybe just a little bit of tea doesn't have much of an effect, on the pH, but if you made a strong, nourishing herbal infusion, as I like to make with the oat straw, and it steeps for many hours as opposed to just 5 or 10 minutes for a regular glass of tea, maybe that will have more of an effect. And so I tried it with oat straw, because that's one of the ones that I use as a nourishing herbal infusion, and I don't really see much of a difference. You might see some. It looks like the oat straw that I fixed as a regular tea is a bit more acidic, and it looks to me like the oat straw that I used as a nourishing herbal infusion with a bunch more oat straw, and it's sealed up overnight. It looks to be not quite as acidic, but both of them ended up on the acid side. And at least for the tea version, I think that pH result is pretty accurate, because that tea, when I put it into the tester, it hardly had any color at all to change the result. Then I grabbed some rose hips and made a nice rose hip tea, which turns out to be slightly acidic, just like most of the other teas, just slightly acidic. But not alkaline. This is one of the ones that is supposed to be an alkaline tea. And then something odd happened. I tried nettle leaf, and I was expecting it to also be slightly acidic like the others, but it scored as alkaline. As you can see here, it's up higher on the scale, and it's actually probably above what this scale shows. I mean, use your own color vision and make your own judgment. One thing that was a little different about this, though, is the nettle leaf tea was green. It wasn't yellow like the other ones were. This one started out with a green tint, and maybe nettle leaves are just that much more alkaline, or maybe the green color got in the way of the color test less, or maybe the green color prejudiced it towards the alkaline side. That's why I need that digital meter. But whatever the reason, for now I'm going to consider nettle leaf to be an alkaline tea. And then I thought, I better test my control, because I also boiled some water and didn't put anything into it, and I expected this to be just the same as when I had started, and so because it's still just water, and hey, water is water, right? So I put it in my tester and I put the drops in, and no, it was not the same. It had become alkaline, and this threw me for a loop for a little bit. I had to go online and do my research. I had to refresh myself on what happens and why this would happen. But it all makes sense. When you boil the water, you're heating it up and you're giving all the water molecules energy. You're giving them enough energy for them to break their chemical bonds and to turn from a liquid into a gas and escape into the atmosphere. But the gases don't all escape evenly. What you end up with is an unevenly balanced charge in the water. You end up with with a lot of ions, and the ions. Let me see unless I flip-flop this, I believe it's to be alkaline. You have a negative charge, so the water is negatively charged, and so that makes it alkaline. Also, any of the alkaline minerals that you had in the water would be more concentrated. Although this water wasn't really boiled that long; it was just boiled, 5 or 10 minutes, and it did this. But yes, if I had boiled it down further and concentrated the minerals that were in it, I would expect it to maybe even be more alkaline. But this really threw me for a loop, and I thought, I have to go deeper into this, experimental rabbit hole here. I have to try more variations. So I boiled some water, and then I let it cool uncovered. I boiled it and let it cool with a plate covering it, and then I boiled it and let it cool inside of a sealed container that was airtight. My theory was that as it was exposed to the atmosphere, it would gradually restore itself to its regular pH. But over the time that it took to cool, it didn't really affect the pH very much at all. And I decided to leave them longer. I left them overnight, and then I checked it in the morning. And I also just set out some water that hadn't been boiled. I thought, what if you just leave out some tap water and let the chemicals in it evaporate overnight? Just let it mingle with the air. What will happen then? The tap water that I set out probably became a little more acidic, it looks like. The boiled water that I left out and that was uncovered all night, it was starting to slide back down towards neutral, but it was still on the alkaline side. So even after being left outside, not outside, but out on the counter all night, exposed to the air, it was still alkaline. It just wasn't as strongly alkaline. And I expect that if I had left it out longer, it would have eventually gone back down to, well, maybe the same as where the tap water was. The boiled water that I had sealed up overnight, it retained its alkalinity because, of course, there was no air for it to interact with to restore the balance and to, exchange electrons with. So if you are boiling water to make it alkaline, which appears to be a very legitimate strategy, it's not super critical to cover it, but if you're going to leave it for a while, I would cover it to maintain the alkalinity. Then I tested some bottled water because in doing my research for this and for an article, I had found that a lot of bottled waters are actually dangerously acidic. I don't mean dangerous like they're going to kill you. We put acids on our teeth a lot, and it's okay. Every time we eat a meal, a lot of our foods are acidic. Our teeth are made to handle that, and then afterwards, the saliva in our mouth gradually restores the pH, and our enamel can reharden, and everything's fine. The problem is if you keep putting acids on your teeth and they never the pH never gets restored and the enamel never gets to reharden, that's when we have a problem. And if you're drinking bottled water throughout the day, sipping on it and thinking that you're just keeping yourself hydrated and thinking this perfectly safe thing, if it's actually acidic enough to dissolve tooth enamel, you may be contributing to tooth damage by drinking water. And yes, there are several bottled waters that are acidic enough to gradually wear down your tooth enamel. Tooth enamel breaks down at a pH of about 5.5. The dentin, which is under the tooth enamel, it can be exposed from wear or tooth damage or at the gum line. It breaks down a little more easily at a pH of 6.5. And I tested the bottled water that we have. We try not to use bottled water, but sometimes it's just really convenient. Sometimes you just have to get some water, and I'm not one of the people that trust fluoride. That's a whole different video, but I'm one of those people. And so sometimes it's just easier to do that. And we have great value, that's like the Walmart brand of bottled water, and look at that, it's acidic. It's definitely down far enough to dissolve dentin. I don't know if it's down far enough to dissolve enamel. I'm going to have to test it with that meter. I decided to boil it and see how alkaline I could make it, and it really only got up to maybe very slightly alkaline. It looks like it's just past neutral on the alkaline side, but it didn't ever get up like the tap water did. Of course, the tap water started at neutral. But, wow, that further discourages me from using the bottled water. And when we're not casually destroying the environment with plastic water bottles, we do like to use water that has gone through our Alexa Pure filter. For those of you that don't know the various different brand names, Alexa Pure is it's a gravity-based filter. It's comparable to the Berkey water filter that's very popular. It filters out fluoride. It filters out the chlorine that's in the water. It's a really nice filter. And I just ran some tap water through it, and it appears to me that the Alexa Pure may have made it slightly more acidic in filtering out whatever was in the water from the the water treatment facility. But when I boiled the Alexa Pure water, it turned alkaline just like the tap water did. So I think we're going to start, or at least I'm going to start boiling my Alexa Pure water and put that in a water bottle for the day. And those are my findings. I hope that they were as interesting for you as they were for me. Moral of the story is boil some water and drink it if you want alkaline water. And not dangerously alkaline. See, people when they're buying alkaline water, they'll buy like the highest number they can, and it's not always good because I mean, acids can damage your teeth, and an acidic diet can be bad for your body, and so therefore getting some more alkaline materials into you can help to neutralize that, but you can swing that door too far that way. But you can swing it too far in that direction, and you can become too far alkaline and damage yourself that way. So I personally am not a fan of the extremely alkaline water. So I think just a slightly alkaline water, something that's still close to neutral, I think that's probably the safest bet. Okay, that's enough of this. Let's fast forward to the morning and see how the other experiments turned out.
It's morning. Hi. Yes, I'm wearing the same shirt. Don't judge me. And let's try my last two experiments. So, as I had said, I thought maybe the lemon rinds might be the magical factor in this. So, I've got just the rinds in water, same amount of water, equivalent amount of lemon that I would have cut, but only the rinds. Let's put it in here. It actually smells really nice because well, the rinds do have citronol. I don't know. It's some essential oil. Boop, 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 boop. Wow. We are acidic again. The lemon rinds also were acidic even after leaving them out overnight. Now, here's the so we got one more option. Okay, we ought to be all rinsed out. In my experiments, I had found that boiled water was alkaline, and then figured out why. And so I thought, what if I did the lemon experiment again, but with boiled water, and then we'll just leave that sealed overnight to preserve the alkalinity. So maybe there's an interaction between the limited amount of air and the lemons, or the lemons and the alkaline water. Is the alkalinity of the boiled water enough to counteract the acidity of the lemons? Because I made such a larger batch, because this will be turned into lemonade later, I went ahead and used the entire lemon. Honestly, I think my prediction is that it's still going to be acidic, that the acidity of the lemons is going to far outdo the alkalinity of the water, because lemons are just really acid, and that pH scale is logarithmic, so every time you go another number down the scale, it's 10 times stronger, and then 10 times stronger than that. So I mean, like, lemons are like, this is something, I may get the wrong number of zeros, but it's something like 10,000 times as acidic as something that's real close to the base, like milk or something. So the alkalinity of to counter that, well, I guess there is a lot of the alkaline water. So maybe the water is not super alkaline. If it was, it might be dangerous. But maybe our volume is going to make up for the fact that the lemons are more intensely acidic. Okay. Let's solve this mystery, and then I'll go put some sugar in this and turn it into lemonade. Wonder if it's bad to take the liquid right by the lemons. I wonder if that's going to mess with it. Alright. Okay, the water is nice and clear. I actually have a couple of little pieces of lemon in that. You know what? That might not affect anything, but I think just to be sure, I'm going to make sure and get a sample that doesn't have little pieces of lemon floating in it, since the lemons would be more acidic. There we go. Also, I'm avoiding the very, very top of the water because there's some floating oil from the lemon rinds at the top layer of the water. And we want to have a more representative sample of the body of the water. So I think I got below that. You know, I'll have to compare it later in the computer software, look at the images, but I don't think it's as acidic as some of the others have been. But it's still an acid. Well, lemon is not an alkaline outside of the body. That doesn't mean that it might not have a net alkalizing effect, because human biology is complicated, and it's not just acid in, acid out through the regulatory processes of your body. We'll just have to have a video or a post on why it is possible to consume something that is acidic and for the net effect to increase your alkaline levels, because you can do it. We're not talking about Harry Potter magic here. We're just talking about chemical reactions and systems that compensate for it. Okay, I think that wraps it up. I hope we have dispelled one particular myth about lemons somehow turning alkaline, lemon water turning alkaline when it's left out for 12 hours. And I hope that we haven't given the false impression that we've somehow proven that lemons can't be alkaline in the body. We didn't actually address that, so we haven't done anything with that. Yeah, so if you want alkaline water, the cheapest ways seem to be to boil it or make some nettle tea. That worked really well too. Happy foraging, everybody, and water boiling. This is a really bad outro. Bye.